Welcome to Inquisitive Kids. In this course, we will be starting to look at permutations and combinatorics, things like that are required for you to know in order to be successful in taking Math Counts and AMC8, which is basically Math Olympiad for middle schoolers. So this is the next level of competitive math as you enter into middle school. AMC8 can be taken maximum for 8th graders, but anyone beneath 8th grade can also take it. 6th graders, 7th graders, even if you're in elementary school and you think you're ready, you can also take the AMC8. So in this video, we will be looking at permutations, its definition. So we're going to learn about what are permutations, and we're going to look at the permutation formula. We're also going to do 4 quick problems that lets us practice calculating permutations. So let's first discuss what is a permutation. A permutation is a way to select a select few of objects out of a total amount of objects. This helps us calculate how many different ways we can select those objects in a order. So that was a bit complicated, but let me show you what I mean. Say that you are putting on stickers for your back to school accordion folder. And on your accordion folder, you have 5 tabs. So you have tab 1, tab 2, tab 3, tab 4, and tab 5. And the accordion folder came with 7 different colored stickers. And each one is the color of the rainbow: red, orange, yellow, green, blue, and purple and pink. So these are the 7 colors that the stickers came in. Now, how can you select 5 colors out of these 7 colors to put in order for your accordion folder? Well, you could just write down every single possibility and write them in the order that you're going to put them in. For example, these tabs are all labeled, right? Like there's always the first flap, the second flap, all the way to the last flap, which is number 5. You could say red, orange, yellow, green, blue. And then you could just continue writing it down like this. But that's going to take a very long time. So this formula, the permutations formula, is what's going to help us find the answer to this type of problem faster. So as you can see, we write a permutation in the form of N, P, and R. So we always include a large letter, a capitalized P, in the middle. And now there are 2 variables that you can insert the number in according to the problem you are solving. So N is the total number of objects that we are taking out of. So in this case, there is a total of 7 stickers. 7 different colored stickers for your accordion folder. So 7 would be our total number. And R will be the number of objects that you're going to take from 7. So you're going to take 5 stickers for each of the 5 tabs on this accordion folder, which means that R in this case is equal to 5. So this is how we would write a permutation for this type of problem. But one thing you have to make sure to figure out the difference between a permutation and a combination. Combination is what we will be learning after permutation. There is a difference. In permutations, the order of how you select things matters. So this is usually when you're solving a problem that has to do with forming a line where there is an order, or a first place, second place, third place where there is an order, or in an accordion folder situation like this where you have the first tab, second tab, third tab, fourth tab, and fifth tab. Permutations always have an order, but in combinations, the order of something does not matter. But we're going to get more into that in the next few videos. Anyways, so now that we have this permutation written down, how do we find the value of it? Well, we can take the variables, or the values that we substitute for the variables, which is N and R, and plug them into this other side of the equation right here. On the top, we have N factorial. A factorial is basically a number followed by an exclamation mark. And for example, if you have 5 factorial, it just means you start with 5 and you keep multiplying the next integers down like this. 5, 4, 3, 2, 1. If you have 100 factorial, that would take a long time to do because you're going to start at 100 and you keep multiplying down. So times 99 times 98, so on. So I think you get the idea of what a factorial is if this is your first time working with factorials. So on the top we put n factorial, which in this case is 7 factorial for us, since 7 is our n. And at the bottom, we take the factorial of the difference between n and r, which is 7 minus 5 factorial. So essentially we have 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 factorial, which is 2 times 1. So we can cancel the top and bottom where they're similar, and then the top, what is remaining would be 7 times 6 times 5 times 4 times 3, which is equal to 2,520. So our final answer for this problem is 2,520. There are 2,520 ways in order for you to select 5 stickers out of 7 stickers and order them according to tab number 1 through 5. So think about how long that would take to write a total of 2,520 possibilities when you could just follow this formula and find it within 2 minutes. This is basically what a permutation is. We are going to take a look at some of these problems right here. They're just small exercises to help us strengthen our understanding of how permutations work and how we can calculate them. So let's start with P83. Now I want you to pause the video and according to this formula, try to first calculate all 4 of these problems and then come back and we'll look at the answers together. Okay, so let's look at the first problem. In here we have P83. In here we have n factorial, which is 8 factorial, over the difference of a 8 and 3 factorial. So this is essentially 8 factorial over 5 factorial. So I'm going to write this out in expanded form so it's easier to calculate, and I'll just omit the 1 because the 1 doesn't really do anything. And on the bottom we have 5 times 4 times 3 times 2. As you can see, the top and the bottom can cancel out, giving us just 8 times 7 times 6. Now 8 times 42 is equal to 336. So our final answer would be 336. Let me write that next to this question right here. That equals 336. If you didn't get 336 for your answer, maybe something happened when you were calculating, or maybe you made a minor mistake. So go back and check your answer. Now let's do P104. So P104 is equal to 10 factorial over 6 factorial, so which is basically 10 minus 4 factorial. 10 factorial, right now it would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And on the bottom, it would be divided by 6 times 5 times 4 times 3 times 2. Now canceling out the top and the bottom, we have 90 times 56. 90 times 56, which gives us 5,040. So the final answer for number 2 would be 5,040. Okay, now let's look at another example. So this next example is P126, okay? It's P126. Here we have P126. The top we have 12 factorial, and on the bottom we have 12 minus 6 factorial, which is 6 factorial. Now, since 6 factorial is 6 times 5 times, and so 6 down, and 12 is 12 down, without having to go through the expanded form, I already know that some parts will cancel out, giving us 12 times 11 times 10 times 8, times 9 times 8 times 7. So this will give us 665,280. So number 3 has an answer of 665,280. Now we have a final problem to look at. And by now I think you are, getting more used to working with factorials and calculating permutations. On the top we have 7 factorial, and on the bottom we have 5 factorial, which is since 5 is the difference of 7 and 2. This gives us 7 times 6, because the remaining part, which is 5 times 4 times 3 times 2 times 1, that has already canceled out. This gives us 42, so our final answer for the final problem is 42. So these 4 answers are the answers you should have gotten. So if you didn't, please go back to your solutions and see where you did it wrong. So in the next few videos, we will be looking at permutations word problems. But it's really important to first be able to calculate permutations, or else even if you did analyze a word problem correctly, you won't be able to accurately solve the problem. So thank you so much for watching 3 Inquisitive Kids. Please subscribe if you would like to be notified when we upload the next videos of this course, and we'll see you next time.